Okay. So this is problem 73 from chapter 29. 73. So here we have a thin metal rod of length L that rotates with some angular velocity omega about an axis and one end. So we have some metal rod of length L that rotates about in one of its axes with some angular velocity omega, and the axis of rotation is parallel to the uniform magnetic field B. So we have some magnetic field that is uniform. Okay, it's just magnetic field everywhere. It's B. This is uniform, and it's parallel to the rotation axis of this rod. Determine the EMF developed by the ends of the rod. Right. So they're asking for the induced EMF. Now, this is because the magnetic field is everywhere. It's uniform and so on and so forth. And this is doing just moving with constant velocity. This has some sort of time translational symmetry, right? So even though, of course, the different positions, it's not completely rotational symmetric. The different positions are different because the rod is going to be at different locations. It doesn't really matter, where I start. It doesn't. The rate of change of this EMF is not going to depend on my angle. So there is some sort of rotational symmetry in that sense. So I find it much easier to work with averages. So rather than writing this as d phi b by dt, I'm just going to say this is delta phi b by delta t. So this is an instantaneous value. This is the average value. But because this motion is uniform, the instantaneous value has to be equal to the average value. And so to get the averages, I think the easiest approach is to take what happens over one period. So my delta t is just going to be one period, and my delta phi b, the total area swept by this rod times the magnetic field, is going to be, so this is just rotating, so it's going to draw a circle of radius L in one period, and it's going to just carry out an area, sweep an area of pi L square times B is going to be the total flux that's swept by this piece of rod. So if I take the ratio, I'm going to get pi L square B divided by T. Now I need to be able to write this T in terms of omega. They are giving me the angular velocity omega, but what is angular velocity omega? Well, this again, using the averages, you go over 2 pi over a period of T, so that's your angular velocity. And so T is just 2 pi over omega. If I substitute this in here, pi L square B over 2 pi, omega moves to numerator, I'm going to get L square B omega divided by 2. Okay? So this will be the EMF that's induced at the two ends of the rod.